Alright, in this video we're going to characterize the PPM signal that's outputted by the receiver of the Traxxas 2019 receiver. This is the receiver, and you can see we have a 5-volt supply. This is the 5-volt supply. We're just using this Arduino board to provide 5 volts into the receiver, and on channel 2 we're pulling out the signal to this breadboard where the oscilloscope, which is this probe right here, is measuring the PPM signal. So this is the signal that is outputted by the receiver with the throttle position all the way at the minimum. You see that the PPM is there's a pulse every 20 milliseconds regardless of what the throttle position is, and so this is the throttle at the minimum position, and we're going to go ahead and adjust the cursor to see approximately what width that is. I'm going to go ahead and move this cursor closer here, just like that, and I'm going to use this trigger right here to move it all the way to the minimum, which is the forward position, and I'm going to go ahead and adjust the cursor. Alright, so this is the minimum. You see the minimum width is about 900 microseconds. You can see that right now, 900. Now if I move the trigger all the way to the back position, so the highest position, I'm going to go ahead and measure the cursor again. So the width of the pulse now is 2 milliseconds. Again, this is the range of the pulse width in this pulse position modulated signal. Alright, so now with this signal we're going to see if we can make the motor run. So I'm first going to go ahead and plug in the signal. Alright. So this is the signal pins that goes into the electronic speed controller, which then will drive that motor over there. So now I'm going to plug in the power. Alright, we heard beeps. Alright. So those four short beeps followed by a long beep means everything is ready. So now I'm going to pull this trigger back and see the motor start to spin. So obviously at the slowest position the motor is off, and then as I increase the throttle position we eventually reach a threshold where it starts to move. And let's see, I'm about at the threshold right now. So you can see as the pulse gets wider, the motor starts to spin faster. Alright. So now what I'm going to do is I'm going to go to measure. I'm going to change it to channel 1 be the positive width. I'm going to go ahead and zoom in more. Alright, so we see the positive width right now is 1.48 milliseconds. Okay, now we're back down to about 900 microseconds. This is again the stop position. Now I'm going to slowly increase this. So at about 1.2 millisecond pulse width, the motor starts to spin. Now here's the 2 millisecond pulse width. This is at the max speed. Again, at 1.2 milliseconds is about the threshold about where it begins to spin. And again, this is a motor without any color on it. So this concludes the video showing how the PPM signal varies with the speed of the motor. Again, about 1.2 millisecond pulse width, the motor starts to spin, and it goes all the way up to 2 millisecond pulse width, where it's the max speed, and we're getting a pulse every 200 milliseconds.